Hello all, welcome to your last flip video of topic 4. 4.6 is called Distance on a Number Line. And while in class we may have taken a different approach in looking at this, I think it'd be easier for the flip video if I just explicitly, directly told you what this is and then we kind of explore it. So let's start there. The distance between two numbers, or 2 points, on a number line is the absolute value of their difference. So I know that's a complex sentence, and there's a lot of information packed into there. So let's break it down really quick. Distance, we know, can never be negative. We also know absolute value can also never be negative. And just a reminder, absolute value is the distance a number is from 0 on the number line. So like absolute value of -3, well, -3 is 3 spots away from 0 on the number line, so the absolute value of -3 is just 3. So absolute value of positive 100. 100 is 100 tick marks away from 0 on the number line, so 0 has an absolute value, 100 has an absolute value of 100. So basically, you find the absolute value by, if it's positive, just leaving the number alone, and if it's negative, chopping off that negative and then using that number. So that's really absolute value. So distance and absolute value are tied together intricately. And then we also have the word difference hidden in here. Difference is the answer to a subtraction problem. So basically, we have two numbers on the number line, and I want to find the distance between them. I'm going to subtract them and then take the absolute value of that subtraction problem. So let's look at a couple examples. What's the distance between the top and bottom of this group of clouds? Well, it's marked for us. The top of it is at 4 1/8 miles, and the bottom is 1 3/4 miles off the ground. So how do you find the difference between the distance between those two? Well, the absolute value of the difference. So we can set this up as 4 1/8 minus 1 3/4, and I'll take the absolute value of that, or I could do the absolute value of 1 3/4 minus 4 1/8. You'll get the exact same answer regardless of which form you choose, because we're looking for the distance on the number line, okay? So I would suggest picking the form that you're more comfortable with. And for most of you, that's going to be the bigger number on the left, smaller number on the right. So in this example, that'd be 4 1/8 minus 1 3/4. I think you'll be more comfortable with this because then it's just a subtraction problem. You're not dipping into the negatives, because a bigger number minus a smaller number is always going to be a positive number, right? 5 minus 3, 8 minus 2, a million minus 100. All of those answers are positive numbers, so you don't have to dip into the negatives. If you're someone who's fine with the negatives, you can do the other one too, and you'll get the exact same answer, because we're taking the absolute value at the end, so it'll chop off that negative. It'll force our answer to be positive. So you can choose whichever one you want. So let's say I like the one with 4 1/8 on the left, so 4 1/8 minus 1 3/4. Well, the first thing we have to do in order to solve this, you can think about absolute values kind of parentheses, so PEMDAS, you always do those first. So we're going to have to simplify what's inside the parentheses, and then we'll take the absolute value as our last step. So how do you subtract 4 1/8 minus 1 3/4? Well, you first got to get common denominators. How do you get to common denominators? Well, you got to have improper fractions. So 4 1/8, how do I get that into an improper fraction? Well, I'm going to multiply the 8 by the 4, which is 32, plus 1, which gives me 33 over 8. I'm going to do the same process with the 1 3/4. 4 times 1 is 4, plus 3 is 7, so 7/4. So great, now I have 33/8 minus 7/4. I still don't have common denominators, so what do? I'm going to scale up the 7 over 4. I'm going to multiply the numerator and the denominator by 2, which is the same thing as multiplying by 2 over 2, which is the same thing as multiplying by 1, which you can multiply any number by 1. You're not changing the value of that number. So 7 times 2 is 14. 4 times 2 is 8. So now I have 33 over 8 minus 14 over 8. So I have common denominator, so I can just subtract now. How do you subtract two numbers with the same denominator? Well, just subtract the numerator. So 33 minus 14 is 19. All right, so we have the absolute value of 19 over 8. And how far is 19 over 8 from 0 on the number line? Well, it's positive, so I just leave it alone, so 19 over 8. But now, if I have 19 over 8, on your digits homework, if you type that in, it would have marked it wrong. you're not supposed to leave improper fractions. Mathematicians like mixed numbers. So how can you split up 19 over 8? Well, you can pull out sets of 8, because 8 over 8 is 1. So I can pull out sets of 8 to get one whole number. So 8 over 8 plus 8 over 8, so that's 16 over 8. So, or 16 out of 19, because there's 19 total in my numerator. So if I pulled out 2 sets of 8, that's pulling out 8. Pulling out another 8, I've pulled out 16 total. So how many do I have left over? Well, I have 3 left over, so I have 8 over 8 plus 8 over 8 plus 3 over 8, which would give me back to 19 over 8. And then I know those 8 over 8s count as 1 apiece, because 8 divided by 8 is 1. So I have 1 set of 1 plus another set of 1 plus 3 over 8, which gives me 2 3/8, because 1 plus 1 is 2, and 2 plus 3/8 is 2 3/8. Okay, so you have to think about absolute value kind of as your last, kind of as parentheses. They're your last step after you do everything inside of them. So let's look at a different problem. This is something we looked at in class, but I'd like to take it one step further. How far is the top of the stratocumulus to the bottom of the top of the abyss? Bottom of stratocumulus to the top of the abyss. So we have a lot of things labeled on here, so you have to really pick and choose the information that you need. But luckily, stratocumulus, the bottom of it, was already labeled for us at 5,000 feet above sea level, and then the abyss starts at negative 13,100 feet below sea level. The abyss will go on to the bottom of the ocean, wherever that ends, but the top is labeled for us, which is nice. So how can I solve this? If I'm trying to find the distance, same thing, absolute value of the difference. So I'm going to do 5,000 minus negative 13,100, or absolute value of negative 13,100 minus 5,000. Both of these will give you the same answer, and so let me show you that. So let's look at the left-hand side first. Absolute value of 5,000 minus negative 13,100 minus a negative is the same thing as adding a positive, so this turns into 5,000 plus 13,100, which is 18,100, so absolute value of 18,100. If I go on the left-hand side, I can do the same thing. I know that's a little hard to see, but you have the negative 13,100 and subtracting 5,000, so 5,000 is positive. We're assuming, if there's no symbol written next to it, you can always assume that number is positive, right? You don't write 2 as positive 2, you just know that 2 means positive 2. So minus 5,000 means minus positive 5,000. Subtracting the negative is the same thing as adding, subtracting the positive, same thing as adding the negative. So negative 13,100 plus negative 5,000 gives me negative 18,100. Let me add that over here. Equals absolute value of negative 18,100. So both of these numbers you have here, absolute value of 18,100 and absolute value of negative 18,100. Both of those are 18,100 away from 0. So if you take the absolute value of both of them, so absolute value of both, I'm going to put a little plus sign here, so like plus and minus, both positive 18,100 and negative 18,100, absolute value of both is just 18,100, okay? So that's why it works for both of them, because you're looking at the difference, the number of spots between them on the number line. So let me prove this to you using the number line. Let's start at the top. You're at that 5,000. How far is it from 5,000 to 0? Well, it's that far. And how big is that space? Well, it's 5,000. That's why the top is at 5,000, the bottom's at 0. It's 5,000 units long. All right, so now let's go down. If I'm at 0 now, and I want to go all the way to the top of the abyss at negative 13,100, it's that far. And how far is that length? Well, 13,100 units. It's that distance. Distance can never be negative, so it's that far away, 13,100. So if I take those two numbers and I add them together, you get 18,100, which is the sum of both of those brackets, the sum of the distances, which is the same thing as what we got a minute ago when we used the absolute value of the differences. All right, so this is why it works, because the number line, you can never go negative distance. So here are two examples we had from in class on the close and check that we didn't get to finish. I'd like to just briefly talk about them. Explain when to use absolute value in solving integer equations and when not to use it. So let's break down the question. When do you use absolute value? When do you use it? When do you not use it? Well, let's look at that. For distance, we use absolute value because distance can never be negative. If you just want the difference between two integers, so if you want to subtract two integers, then you do not use absolute value. So you only use absolute value when you want distance. If you just want to subtract, you don't use absolute value because then you'll get an inaccurate answer. You'll get the forced positive because absolute value chops off the negatives because it's saying for distance. So you'd be changing your answer. So you only use absolute value when you want distance. Otherwise, you don't need the absolute value. All right. Error analysis number 5. The Roman Empire lasted from 27 BC to 476 AD. Using 0 as the division between BC and AD, a classmate says he can find the total length of the Roman Empire using the equation negative 27 plus 476 equals x. I'm going to assume it means x is the length of the empire's life. Is he correct? Explain. So let's look at that. Whoops. Sorry about that. So important information here, 27 BC to 476 AD. So let's make a quick number line. So this is not drawn to scale, nor is it complete. I've only marked off 3 numbers here, so you have 0 right in the middle, 27 BC over to the right, and then 476 over to the right. So clearly not to scale, right? The 27 looks almost the same length as 476. So using the trick we just used in the abyss and problem, let's see how we can find the length of this for total length, so distance. Well, 0 to 27 is 27, 0 to 476 is 476, so if you add those together, you get 503. Okay, so the length of the Roman Empire was 503 years. Now let's try it using our definition. The distance between two numbers on the number line is the absolute value of their difference, so we can do, I've added BC and AD here just so it's a little bit clearer. Absolute value of negative 27, because 27 BC is to the left of 0, so it's negative. And I know that's hard to think about. Time was negative, but objectively humans have decided that year 0 was 0, and anything before that was negative. We denote that negative by using BC. You can't go negative time, you know that. It's like distance. You can never go backwards in time. You can't go a negative distance. So time, we say, instead of negative 27, we say 27 BC. So you have absolute value of negative 27 minus 476, which is the exact same thing as the absolute value of 476 minus negative 26. Right? Because you can rewrite it, you can flip-flop the order. Absolute value will take care of the negative issue. So let's do the 476 minus negative 26. Subtracting the negative is the same thing as adding the positive. So 476 plus 26 is the absolute value is 503. So we have the absolute value of 503. Absolute value of 503 is 503, which gives us the same answer as what we got from adding the pieces on the number line. All right, so here are 2 problems you'd see on your homework. Find the distance between negative 478 and 264. So we're looking for distance, negative 478 and 264. So the absolute value of negative 478 minus 264, which is the same thing as the absolute value of 264 minus negative 478. I like the one on the right because then you go from negative to subtracting a negative to adding the positive. So absolute value of 264 plus 487 gives me the absolute value of 751, which is just 751. If you did it for the left-hand side, you get the exact same answer. If you would like to do that, you're more than welcome to. All right, here's another problem. Mishka dives from a platform that's 7.5 meters above water. Her dive takes 2.8 meters below the surface of the water. How far does Mika's dive take her? So for problems like this, I think it's helpful to draw a picture. So here's the important information: 7.5 meters above the water, 2.8 below surface after the dive. So here's a little platform, here's the water, the black line at the bottom is the bottom of the water. We didn't need to draw that in, but I think it's helpful for you to visualize it. So we have Mishka standing on top of the platform, and we have that platform is 7.5 meters above the surface of the water. So she jumps in, she's now in the water, she's 2.8 meters below the surface. So this water level, the surface of the water, is our 0. So when she's at 2.8 meters below, if this was a number line, you could think about that 2.8 meters below as negative 2.8. So let's find the distance, how far distance, right? You answer the question, how far away is something from something else? Well, you say the distance between the two. So we know distance, 7.5 minus negative 2.8. Again, the water level would be 0. So 2.8 meters below would be like negative 2.8, all right? We could rewrite this as the absolute value of negative 2.8 minus 7.5, exact same thing. I like the top one because then I can subtract a negative and to add a positive. 7.5 plus 2.8, we're going to take the absolute value of that. So the absolute value of 10.3, because 7.5 plus 2.8 is 10.3. Absolute value of 10.3 is just 10.3 meters. So she started up 7.5 meters above the water, jumped in, went 2.8 below. How far total did she go? She went 10.3 meters. All right, let me know if you have any questions. This is the last flip video of topic 4. You'll have an assessment upcoming, so make sure you go back and review and make sure you know all of the material in topic 4.